All right, my lovelies, here is our discussion on section 1-1. This is the Earth's changing surface. Now, I'm going to go pretty quickly through this because you've read this section, and so I don't want to be boring you. I just want to point out some things to make sure that you saw them. First of all, we know that the Earth's surface is under stress, and those are three types of stress that we deal with the Earth, and that is the compression, when things are being pushed together. There's tension, when things are being pulled apart. And then there's shearing, and that's when things are sliding past each other. Now this stress, this can cause the rocks of the crust to change. That's what this triangle means, change in volume. It can change their shape, and it can also cause them to crack, which is what we call fracture. So just like, you know, if you have a broken bone, you have a fracture in your bone, that's a crack, okay? Now, if they do crack, causing this fracture, then, and they move along the crack, okay, so if they just crack and they stay there, it's just a fracture. But if they crack and the rock is moving along that crack, that's when we have this whole thing called a fault. And if we have a fault, we have two sides of a fault. If it cracks along this way, here's our fault. We have the part that it points up and is above that. This is our hanging wall. See, this is like the bigger part is on top. And then we have the foot wall where the larger part is on bottom. Now, if we have tension, that's pulling, if we have tension, then we generally have our hanging wall on this side comes down, and our foot wall tends to go up as they're being pulled apart because the hanging wall is kind of sliding down this incline. This is what is called a normal fault. Okay, there's vertical movement. The foot goes up, the hanging wall goes down. If you have compression, all right, pushing along this fault, we have the hanging wall pushing up and the foot wall coming down, and this is called a reverse fault. But both of these faults, the movement is vertical, up and down. So we have either the hanging wall goes up on top in reverse, or the hanging wall goes down in a normal. Now, a special case of this reverse is when the hanging wall, all right, so things are being compressed, so over here is our foot wall, over here is our hanging wall, but when the hanging wall is pushed and it causes it not just to go up, but to kind of curl over it or to slide on top, and this is called a thrust fault. And instead of having vertical movement where things move up and down, this one you have horizontal movement. It goes left and right. So you have a little bit of up and down where the hanging wall goes up a little bit, but most of it, the movement is side to side. Now, for our rock layers, the normal orders, we're going to have young rock on top and old rock down towards the bottom. And in a normal and a reverse fault, you see that. So if you're driving along the road and you see these layers, and you see the layers don't add up, you know, they're shifted away from each other, those are our faults. But in a thrust fault, because of the way the hanging wall kind of grinds over top, it mixes all of the rocks up, and it puts old rock from the hanging wall on top of young rock from the foot wall, and so the order gets all messed up.